Perfect. Having explained this topic well, let's move on to do follow-ups on the outer plates so that you can now identify or understand how electricity travels through electronic plates. That's what we're going to try to do, gradually understanding all the circuits. You are seeing an inverter electronic plate here. Now I'll zoom in a bit. Starting on this side, I'd better turn it over because the words are written backwards. At this point here we have the line and the neutral. Here we have communication or signal. We'll talk more about that later. The line will go through a fuse and continue its journey, line and neutral. Here we have the varistors, here the ground discharge. The ground discharge also has a small connection with some capacitors that also do stabilization or final filtering. You can also see some small capacitors of this format on this side. We reach this point, cross from one side to the other the toroidal coils of the filter. We have some final capacitors again. Here we cross a small contact relay. Here we have a filtering capacitor for low capacity. Capacitors, and finally with the two in the middle we reach the rectifier input. The alternating current input of the rectifier, and at both ends we already come out with rectified voltage. If we ignore some things that we have here in the middle, which I will explain later, we will then reach the filtering capacitors. Rectification, and here we have filtering done with capacitors, 8 of 100, they are 800 microfarads that are filtering this area. This that I just skipped is what we are going to talk about next, which is the power factor correction circuit or PFC. We will talk about that later. We will do the same on the LG plate. I'm going to take it out of here. Well, here we have neutral and line. We cross a fuse. Yes, this is the fuse. Here we go towards the capacitors and the ground derivation we have here in this area, then to a winding and another winding. Look how these LG low-pass filter coils are a little smaller. Here we have a filtering capacitor too. It doesn't have two but only one. It's not double pi format. We continue our journey crossing a small fuse more. And what we do here is skip a component that is connected in these two cables, which is part of the PFC circuit that we are going to talk about next. This component produces a union of the two cables simply. But if we continue along the route, we find alternating voltage or alternating voltage input of the rectifier. Here we can see the rectifier. And if we look at the rectified output, here we have negative that follows this route and goes towards here. And here we have the positive that comes towards here and reaches this end, and what do we have here? At this point we have the capacitor. In this case, this LG has only one capacitor of 680 microfarads, and here is where voltage is filtered. So here you have source zone of outdoor unit, but their source does not end. Remember that now we must go to switched source. These plates have switched sources. It is true, this filtering, this voltage of 310, if you have 220, it will go to the motor. We will explain that later. We still have to go through more components, but this will also go to the switched source. And if you observe, Here we have the positive and here we have the negative. Look at the negative. We reach this side of this component and skip to the other side. This component of 7, remember that it was the switch. There we have the switch, and then we come to the ferrite transformer, to the coil of the ferrite transformer, and the positive. These arrows are only jumpers, that's why there is the letter J. It goes straight to it, to the transformer. I'm going to show you these jumpers on the other side. There you have it. Very well, we cross the transformer, and on the other side of the transformer, if we follow tracks, notice that we are going to find a diode here. There, I show it to you. Notice that we are seeing all this from above. What do I mean? That without disassembling almost anything from the air conditioner, all this is exposed to us, and you will be able to make all these visualizations. Here we have evidently an output from the transformer. It crosses a diode that must be half-wave rectification. We follow tracks, continue, and here we have this checkpoint of 15 volts. Between this point 15 volts and this one that says GND, I must have 15 volts. So this transformer has an output of 15 on one side. If we go towards another side, let's go towards here. Evidently this is negative. It is negative because it says GND, it is wider. Notice that this is all united towards here. It is united to all this is negative, and I have to find positive of 5 volts. If we go towards this side, we cross a component that is half-wave rectification diode. We come towards here, and we are entering this component of 3. Evidently this must be a 7805 because on this side that I know is output, notice that we are going exactly towards this point, which is a checkpoint of 5 volts. Evidently about 12 or 15 will enter here as well and regulates for 5. I'm going to show it to you on the other side, and we're going to identify these two half-wave rectification diodes. So here we have everything we just mentioned. Half-wave rectifiers, here we have filtering capacitors, and here we have 7805. There it is clearly visible. Well, as soon as I disassemble a unit, I don't have access to this part of the plate, but if I have access to the other side, and little by little you will become familiar with all this and will be able to do your tests from here. In fact, we are going to do some measurements in the following classes, and the idea is that you can also do them. My idea is always the same, that you can diagnose an inverter circuit without disassembling all equipment or disassembling as little as possible. With this we are finishing with what is source zone. Shall we go with the other plate? This electronic plate, after capacitors, I also have to go towards switcher. This electronic plate is more complex because it has tracks on both sides, but still I will have many test points on this side. Notice that here there are a lot of checkpoint of 0.6 volts, of 1.8 checkpoint of 15 volts. Here I have another checkpoint of 12. What I don't see here is switcher. Here it's not visible because it's mounted on other side like a device that mounts without crossing plate. Transformer does crossplate and we'll see it on other side. In this case, in this plate, maybe it's necessary to disassemble a little more to make these measurements. But here we have the capacitors, the switch, the components that surround the switched power supply, and some electrical resistance. Those are diodes that do not cross. They are mounted superficially SMD. Here we have the optocoupler. Here we have the transformer, and on the other side half-wave rectifier circuit that has the mounted diode and the last capacitors. Here we are reaching the end of the source of the outdoor unit. Any problem in the source area, the electronic plate directly does not work because this is what prepares the voltage to power the microprocessor that commands everything else, that warns us of error codes, etc. Everything we've been seeing, the rectifier, capacitors, and switched source are part of source that powers control zone.